In this video, we're going to talk about applications of linear equations in two variables. So, for the following problems, write variables and explain what they mean, create a table if necessary, write a system of equations, and then solve. So, Tom spent $7.75 on 3 drinks and 2 candy bars, and Emily spent $8.25 on 5 drinks and 1 candy bar. Determine the price for 1 candy bar and 1 drink. So, first thing we need to do is to determine what the price of 1 candy bar and 1 drink are. Those are our unknowns. So, let's do D is equal to the cost of 1 drink, and C is the cost of 1 candy bar. Now, let's take a look at each person. Let's start with Tom. 3 drinks, that's 3D. Adding it to, well, 2 candy bars, that's 2C. And the total is $7.75. Now, let's go to Emily. 5 drinks, 5D. Add that to the cost of 1 candy bar, and that's equal to $8.25. So, there's 2 ways to solve these systems algebraically: substitution and elimination. I'm going to use elimination in this case, and I'm going to eliminate C. So, I'm going to multiply the bottom by -2. Distribute the -2 to each term. And now add the equations. So I have -7D, the C subtract out, and it's equal to -875. Divide both sides by -7, and you have D is equal to 125. Now, I need to go back to one of the original equations to calculate what C is. Let's go to the bottom equation. So replace D with $1.25. 5 times $1.25 is $6.25. Subtract 625 from both sides, and C is equal to 2. Now, I'm going to replace C equal to 2 and D for $1.25 in the top equation to make sure that this is a solution there also. As I have shown here, it is. So let's write a sentence to summarize. 1 drink costs $1.25. And 1 candy bar costs $2. Okay, let's take a look at the next example. So a pharmacist needs 8 ounces of a solution that is 50% saline. How many ounces of 60% and 20% solution must be mixed to obtain the mixture? All right, so the 2 unknowns are the ounces of 60% saline and ounces of 20% saline. So let's write it out. S equal to ounces of 60% saline and T is ounces of 20% saline. All right, so I've already started the table for us. Notice 60%, 20%. Always the mixture I will always put on the bottom in our columns. Ounces of saline, percent pure saline, and ounces of pure saline solution. Well, ounces of 60%, that was represented by S. Percent, I changed that to a decimal. That's 6/10. Multiply, that's 6/10 S. 20%, we need to talk about the ounces of 20% solution. That's T. Write that as a decimal. That's 2/10. Multiply, that is 2/10 T. So, thanks to the example here, we know we need 8 ounces of 50%. Write that as a decimal. And 8 times 5/10 is 4. So, where are our equations? Well, the column with the ounces of saline, S plus T is equal to 8. And the other equation is for the ounces of pure saline solution column. So that's 6/10 S plus 2/10 T is equal to 4. All right, so I'm going to solve this system by substitution. I'm going to solve the top equation for S. So subtract T. And now I'm going to substitute this into the bottom equation. So I'm going to replace the S with 8 minus T. Distribute. Combine like terms. Subtract the 4 and 8/10. And then divide by -4/10. So that's T is equal to 2. So I'm going to substitute the top equation T for 2. And we can tell very quickly that S is equal to 6. So we know this works for the top. We now need to check to make sure that S equal to 6 and T equal to 2 works for the bottom equation. As we can very well see, that is the case here. So let's write a solution to determine what we just calculated. So the pharmacist needs 6 ounces of 60% saline solution and 4 ounces, not 4 ounces, 2 ounces of 20% saline solution.